Hello everybody, welcome to this channel. I'm Peyman Hisari. In this tutorial, I'm going to talk about elbow technique in k-means clustering and how to implement it in RapidMiner. The dataset that I use is called mall customer, which can be easily found on internet, and I will put the link to the dataset in the description. This dataset contains basic information about mall customers, which can be used to segment them into different groups based on their purchasing behavior. Let's bring the dataset into the process panel first and take a look at the data. As you see, I have 200 data points or examples, along with 5 regular attributes. The attributes is user ID, gender, age, annual income, as well as spending score. Let's take a look at the statistic. Customer ID is a unique ID for each customer. It is integer and there is no missing value for this feature. Gender is nominal, there is no missing value, and we have two gender, male and female. For age, it is integer, there is no missing values. The youngest is 18 and the oldest customer is 17 years of old. And the average age of the customer is 39 years old. Annual income, it is the data type is integer, there is no missing value. The minimum of annual income is 15K and the maximum is 137K. And the average annual income is 60K. And the spending score, again, it is integer. There is no missing values. The minimum is 1, the maximum is 99, and the average of a spending score is 50. Go back to the design. And in order to do the analysis, what I'm going to do is to remove some of the features and select only some of them. And in order to do that, I use an operator called select attribute. Bring the select attribute operator here, connect these two operators together, and configure this operator. Type, I'm going to include those features that I'm going to use. Attribute filter type, I'm going to use a subset of them. And the attributes that I'm going to use is age, annual income, and spending score. I don't use customer ID because it is unique to each customer, so it does not add any value in order to do the analysis. And gender is categorical variable. If I want to use it, first I need to convert it to numerical. There is an operator called nominal to numerical that can do that. But for the analysis and for the simplicity, I'm not going to do that now. Apply, and let's take a look at the data again. And now, as you see, still I have 200 example. Now I only have 3 regular attributes. The next step, in order to do the k-means algorithm, is to normalize the data. And in order to do that, I use an operator called normalize. Bring the normalize operator here, connect these two operators together, and configure this one. The attribute filter type can be all, single, a subset, or can be chosen based on some regular expression or based on some value type. But here I'm going to choose all of them because all of the features should be normalized. And for the method, I can choose Z transformation, which basically means that the data after transformation would have 0 mean and unique standard variation. And if I use range transformation, the data after transformation would have a specific range like between 0 and 1. And proportion, the data after transformation would be divided by the sum of that column. And we can use interquartile range as well. So I'm going to choose Z transformation. And if I want to take a look at the data after normalizing, then the data looks like this. The next step is to run k-means using different values of k and calculate average within centroid distances for each model. In order to do that, I use an operator called loop parameters. Bring the operator here, connect it to normalize operator, and double click on this one. It will open up a new subprocess panel. And here you need to bring the k-means operator, connect it to the input. And for simplicity, I'm not going to configure this k-means operator, but I need to calculate the performance. And in order to do that, I use an operator called cluster distance performance. Bring the operator here. And here you need to be careful. Make sure you have the right connections. And configure this one. The main criterion, we are going to choose average within centroid distance and make sure that you normalize and maximize it. And connect the performance to the output as well as the data. And go back to the process and configure loop parameters operator. And click on edit parameter settings. And here the operators is k-means, and for k-means I'm going to choose k, and for k there is a minimum and maximum. The minimum is 2, the maximum I'm going to choose 10, and the step I'm going to choose 10, and for a scale you can choose different scales, and this is the values that you will see that the model will run over for k. From 2, 3, 4 to 9 and 10. And click on OK. And I'm not going to change any other parameters here. Connect this one to the output and run the process. So here we have the clusters. And if I take a look at the loop parameters, I see different values for k along with average within centroid distances. And in order to take a look at the elbow graph, click on plot view, change the chart type to series. Index dimension should be clustering k, and plot series should be average within centroid distance. And as you can see here, probably 4 is the right value for k, or optimal value for k. And this is what I'm going to choose and apply k-means on this data set and analyze it. Let's take a look at that in the next video.